Welcome to Cruz Learning, where it's just that easy. With your favorite host, Professor Cruz, and today we're going to talk about graphing linear inequalities and systems of linear inequalities. So the first things first, we're only going to graph a single simple linear inequality. So let's say that I give you y it's greater than, it's just greater than or equal to 3x plus 5, okay? So I ask you to graph this. Notice that this is the same thing as y equals mx plus b. We're gonna graph it almost the same way. Okay. So the first thing we're gonna do is that when I have my Cartesian plane or my coordinate plane, this is x and this is y. Okay. The first thing, hopefully you already know how to graph this. The y-intercept is 5. So this is definitely going to cross 5. Okay, so 5 is there for the y-axis. Actually, let me do that in black so that it stays consistent with the drawing. And then I have 3x. So I'm not going to be too picky. All I care right now is that the slope is positive, so it's going to increase from left to right. And the y-intercept is 5. So I'm going to have a point here, and I'm going to increase. This is how I'm going to graph it, right? Now, I have to take in consideration two things. Number one, that line that I just drew could be solid, and that one is solid, or it could be dashed or dotted. So some places write it in different ways, okay? So it could be dashed or dotted. It's the same thing. So a dashed line or a dotted line, okay? So a solid line is just a solid line, a dashed line, okay, with dashes or dotted, depending on the equation, the platform that you're in. These two mean the same thing. So solid. How do you know if I should graph a solid line? Well, because I have the equal to sign. You see, every time that we graph equals equations, right, we just draw a solid line. So if I have the greater than or equal to sign or the less than or equal to sign, I'm going to use that solid line when I'm graphing, okay, when I will graph with that. And if I have only greater than or only less than, then I'm going to use my dash line or dotted line, same thing, okay? So in this particular problem, which is the first example that I'm using to explain this, because it is greater than or equal to, it qualifies to be a solid line. And what I think is that, remember, the equal to sign at the bottom below fills in the gap. So if there's no equal to, there's going to be a dash in the middle, right? But if there is an equal to sign, there is no gap in the middle because it fills it in. So that's how I think about it. All right, so now that we graph the line, this is still not done because then I need to decide, do I graph or do I shade, I should say, do I shade above? Do I shade above or below? Okay, what do I mean by that? Well, when I graph, am I going to shade above the line or I'm going to shade below the line? Because what happens is when I'm looking at the solution of an inequality, the points on the line are no longer the only points, but it's a half of a plane. So, for example, because this says greater than, I'm going to shade above. Okay, so if I have that y is greater than, I'm going to shade above. Notice that y is always first. Y has to be first in order for me to follow those instructions. If my problem says y is minus or less than, then I'm going to shade below because minus means below. Okay, less than means below. So here we go. Because this is y is greater than or equal to, then I'm going to come here and I'm going to shade above my line. And I'm going to use that highlighted so that you can see that every single point above the line is a solution, including the points on the line. Okay, all those are solutions because it says greater than or equal to. None of the points down here, none of the points in this region of the graph are solutions because that is not shaded. And we always shade the side that contains the solution. So hopefully that makes sense. Let me give you another example, right? Let me give you another example. What happens if I give you, or if I tell you that y is less than and just less than, okay, let's do 5x plus 1. Why not? 5x plus 1. So again, if I want to graph this, let's go in order. The first thing that we graph is the y-intercept. Okay, so I'm going to graph it right here. First thing that we graph, let me write it down so you have steps. The first step is the y-intercept. So the y-intercept is positive 1. It's positive again, and it's positive 1. There's a point there, okay? And my slope is positive, okay? Now, if I had a grid, the slope, okay, so I'm going to use slope to plot your next point, right? Use slope. And the slope here is 5. Okay, so m equals 5. Again, this is y equals mx plus b. But a slope is a fraction. It's rise over run. So from here, I have to go up 5. 1, 2, 3, 4, 5. And then you're going to go over 1. So then when you go over 1, you have another point. So let me do this one in blue. So you have a point 6. This went all the way up to 6 because it went up 5 units and it went over 1. Okay, so I have my 2 points. The question that I have right now is this going to be a dashed line or a solid line? Okay, so is it solid or dashed? And in this problem, okay, this is going to be a dashed line because there's no equal to, right? It's just less than. And because there's no equal to, it doesn't fill in the gap. So therefore, this is going to be dashed. So I hope that makes sense to you. The last step is to shade the correct half plane. Okay, half plane. We need to shade the correct half plane. So am I going to shade above the line or below the line? Well, in order to do that or to know that, I'll have to look at the inequality sign one more time. That says that y is less than. Y is less than. Because y is less than, I'm going to shade below. Okay, I'm going to shade below the line. Below the line. So that is the region that contains all the solutions. Now, I can ask you different things. Like, for example, is 0, 0 a solution to that inequality, right? I could ask that. Well, if I look at the graph, where is 0, 0? That point is here. Is that point within the shaded region? The answer is yes. So therefore, that is yes. Any point that it's on that region, it will be a solution. I could ask, is the point -3, 5 a solution? Well, the point -3, 5 is somewhere here. And what happens is that is not in the shaded region. Therefore, the answer here will be no. That is not a solution. My last question to you is the point 0, 1 a solution? Well, if I look at my graph, the point 0, 1 is actually graphed already right there. Is that blue point right there? So you might be tempted to say yes is a solution, but the answer is no. That is not a solution. Does anybody know why? Do you know why? I'll tell you right now. Because the problem says that y is less than 5x plus 1. So the reason why we drew a dashed line is because none of the points are solutions. These points are no solutions. Those are no solutions for this inequality. See, if I take x and I replace it in my inequality, and I take 1 and I replace it in my inequality, so my inequality is y is less than 5x plus 1. I'm going to plug in, right? I'm going to substitute. So this is x and this is y. And I'm going to plug in 1 for y. Okay. And I'm going to plug in 0 for x. And the moment I do that, when I simplify, I get that 1 is less than 5 times 0 is just 0, 1. Is this a true statement? Is 1 less than 1? That is completely not a true statement. That is a contradiction. Okay, that's a contradiction. That is not true. And the reason why this is not true is because 1 equals 1. So, if the problem was different, the only thing that could change my answer is if I have less than or equal to. If this problem was less than or equal to, then I will have a solid line, and every single point on that line will be a solution, just like in a regular equation. But the moment I take the equal to sign away, then the answer becomes no. So that equal to sign makes a difference. Okay, so it's very, very important that you know that. All right, so let's do the problem that it's given to us right here, right now live. They say graph the line 1x plus 1y is less than or equal to 2. So the best thing to do here is to solve for y so that you can have y equals mx plus b. So I'm going to take that x and move it to the other side of the inequality sign. So I treat the inequality sign just like if I would treat a regular equal sign. Okay, so I'm going to have that y equals less than or equal to, and when I move the 1x from one side to the other of the inequality, it also changes sign, right? So it'll be negative 1x plus 2. If I do this, let's graph it. So find a y-intercept and plot it. That will be positive 2, okay? And then I have a negative slope of negative 1 over 1. So I'm going to move 1 down and 1 over. So 1 down and 1 to the right. Okay. And then because this is a solid line, because it says equal to, so that equal to, it's going to make it a solid line. So I'm just going to, that was interesting zoom. All right. There you go. There you go. So it's going to look something like that. It's going to be a solid line. And then I have to decide, am I going to shade above the line or below the line? Well, I always have to look at the y equals mx plus b. And the y equals mx plus b tells me that it's less than, so I'm going to shade below. Okay, I'm going to tell you a common mistake that I see many people do. Many people shade looking at the slope, and they say, oh, because x is negative, I'm going to go below the line. That is not correct, and I never wrote that down. Okay, the negative slope tells you if the line is increasing or decreasing from left to right. So in this problem, as you can see, this is a negative slope because if I try to draw this line from left to right, I have to go down from left to right. Okay, but I shade below because that is less than or equal to. If it was greater than or equal to, then I will shade above. All right, so that's how you graph that. I hope that that makes sense. The line was graphed there for us. This is not that bad. The way that I will do this, first of all, you have to try to make sure that they're all in the format of y equals mx plus b. So I will rewrite, for example, b and c are not in the format y equals mx plus b. I will have to move. Let's do this one way, right? I'm going to do b one way, and one way is moving the negative 2 to the other side. If I move the negative 2 to the other side, I'm going to have x plus 2, because 2 is going to change sign. It's going to be greater than or equal to y. And y is on the right. I don't want y on the right. I want y on the left. Now I'm going to go very simple, very basic here so that you can get the right answer. You always want y on the left. So all you have to do is write down y. Okay, so oops, I'm going to write down y right next to it. Okay, so I'm going to rewrite this. And I'm going to think, look at your sign. Is the pointy side with y or is it the open side with y? Well, hopefully you can see when you look at the inequality sign, the pointy side is the one that is pointing to y. So I want to make sure that the pointy side is still with y, because if not, that will change the meaning of my expression. So I'm going to flip it. I'm going to flip everything, and I'm going to have x plus 2. So look what I did. The pointy side still with y. This is rewritten so that I can see the slope and the y-intercept. If I attempt to do the same thing with c, right? So I'll do the same thing. Then it'll be x minus 2 this time. And it'll still be greater than or equal to y. And then when I flip it, it's going to be y is less than or equal to x minus 2. And that will be c. Okay, so I have the y-intercept, the slope, etc., etc. For d, I can rewrite that very easily. All I have to do is move the 2x to the other side. So I'm going to have y is greater than negative, well, greater than or equal to negative 2x, okay, plus 1. The only one that changed was the negative 2x because I moved it. Okay, so that's how you would do that. When I look at e, and I'm going to do e down here, so it is better space. Okay, let me fix this because it's driving me crazy. There you go. So I'm going to have 2y is less than or equal to negative x. I'm moving the x, so negative x plus 1, not moving the 1. Okay, when I have this, now y is not by itself, so I'm going to have to divide every single term by 2. Okay, by 2. This cancels, and it's going to give me that y is less than or equal to, all right, negative 1/2 x plus 1/2. And then, again, I can see the y-intercept, which is this 1/2, and I can see the slope, which is negative 1/2. Now, just pay attention. If you end up dividing by a negative number at any point, remember to flip the inequality sign. All right, perfect. So if I look at the first inequality and the first graph, which inequality does this one represent? All right, which one does it represent? Well, what is my y-intercept? My y-intercept is 1. So because the y-intercept is positive 1, it has to be one of these 3. It has to be one of those 3 because those are the ones that have y-intercept 1, right? This is D and the y-intercept is 1. This is actually is not E because the y-intercept here is 1/2, so definitely not that one. And it could be F as well. Okay, so let me solve for F actually, and I'm gonna do it right here. So if I solve for F, I'm gonna write it in red. That's gonna be y. Oops, y is less than or equal to negative 2x plus 1. Okay, so the answer is either D or F. What is the difference between D and F? Because they look almost identical. Well, the inequality sign is the difference. One says greater than, the other one says less than. So when I look at this line, where am I going to shade? Am I going to shade above the line or below the line? I'm supposed to shade, this is shaded above, by the way, because here's the line. And I have, from the line, I have to move up to be able to shade, right? I have to move up. So therefore, the correct answer here, if I have to move up, will be D. D is the answer for that one. Okay. If I look at this one as well, then the y-intercept is negative 2. So it's definitely one of the first. It's either A or C. Okay, A or C. And then I have to look at the slope. The slope is a positive slope. So A has a positive slope, and it goes up 1 and over 1. Okay. C has a positive slope as well. So it goes up 1 and over 1. The question is, do I shade above or do I shade below? So when you look at that line, is it shaded above or below the line? You have to move from the line. From the line, you will have to shade down, right? From the line, you have to shade down. So it has to be less than. The answer will be C. Okay, the answer for this will be C. And then over here, it looks like the answer is A. It's the same thing. It's exactly the same graph. I hope that you can see it. It's just shaded above. Okay, so that's how you do that problem. Let me see if there's any other problem that I want to do. Well, there's one more problem that I have to do, and then we're going to do the system, and then we're going to be done. The system is just one problem, which is great. I want to point out, just in case, what happens if I ask you to graph only y greater than 3 or x greater than negative 5. Okay, well, if I want y greater than 3, I just find 3. Let's make a negative 3. Why not? Let's make a negative 3. So I'm going to find negative 3, okay, on the y-axis, because that says y. And is it dashed or is it solid? Well, it's going to be dashed, right? So I'm going to make a dashed. And am I going to shade above or below negative 3? Well, that says y is greater. So I'm going to shade above negative 3. So everything up here is a solution. Every single number up there. How about x is greater than negative 5? Well, I'm going to make it x is greater than or equal to negative 5. Well, I'm going to find negative 5 on the x-axis. So there is negative 5. And then because I just added the equal to, that's definitely going to be a solid line at negative 5 because that's the one that it is. And it says greater than or equal to negative 5. So where are the numbers in the number line for the x-axis? Greater than negative 5. To the left of that line or to the right of that line? It is definitely to the right of that line. That's where the greater numbers are. So that will be the answer. Okay. All right, here we go. The last exercise. Are you ready for the last exercise? Here we go. We want to, and they say, pick two inequalities whose intersection is the shaded region. Okay, so let me explain this to you. A system of inequalities, just like a system of equations, is a system that has two or more inequalities. In this problem, we're only going to use two, right? We're only going to use two. So when you look at this, when you look at that right there, what you can see is that there's two inequalities, okay? And what happened was that the inequality, so I'm going to do the red line. The red inequality was shaded below, okay? The red inequality was shaded below, so that was less than equality. And the blue one was shaded above, okay? The blue one was shaded above. Now, because there's two of them, the system of inequality only has solution wherever all solutions cross, where all the shaded regions cross. And it looks like if I were to name this 1, 2, 3, and 4, the only region where they cross is at 4. Therefore, that is the solution to the inequality, because it has to be true for both inequalities. If I try to ask for the point, the solution of the point or the point of intersection or anything like that, all these intersect in section 4. There is two things that could happen. Okay, there's two things, or there's many things that could happen. But if I have a line like this, and I have a line like this, okay, and I do, this was greater than, if that was greater than, this was less than, where do they intersect? They don't intersect anywhere. Because they don't intersect anywhere, there's no solution. Okay, there's no, oops, what the heck, if I can spell? There's no solution. It does not exist because they never cross. Now, what would happen if I graph exactly the same thing, exactly the same inequality graph, but I care about everything above the blue line and everything below the red line? Well, you might be tempted to say that this is infinitely many solutions, which it is, but it's not all real numbers. It is not all real numbers, because the only place where this is a solution is where they cross. And the only place where they cross is in the middle. It's inside, okay? It's inside. So it's very, very, very important that you take into consideration when it comes to systems of equations, is not the region that you cover in the graph, is the region where they intersect, where the shaded regions intersect. So this part is the solution. Are there infinitely many solutions? Yes, because there's infinitely many numbers in there. But it's not all real numbers. So you have to be very careful. All right, so here we go. Let's try to find out the equations over here. The only one that I have written over there is in y equals mx plus b is that one. And it says that the y-intercept is a -3. Do any of the equations that I have y-intercept by -3? No, they don't. So that's definitely not one of my answers. Let's go in order. Let's pick the first one. So can I rewrite this in y equals mx plus b? Of course I can. All I have to do is flip it. So y, now the open side is with y. So I'm going to rewrite the open side with y. And then I rewrite the rest. 1x minus 2. What is the y-intercept? Is that y equals mx plus b? Yes. The y-intercept is -2. So I just want to make sure that you're on the same page with me. Y equals mx plus b. B is the y-intercept. So the number by itself is -2 right here. So that's good. The blue line looks like that's the y-intercept. The slope is 1. So I have to go up 1 over 1. So if I go up 1 and I go over 1, I end up in that point right there. That's perfect. The question is that shaded above? Remember, now you're not done because now you have an inequality sign. And it looks like, yes, you're shaded above. This has to be above because, remember, this is greater than. So greater than means above. And the answer is yes, it is above. So that line is the inequality for my blue region. For my blue, okay, so this is the blue region. So this is definitely, you have to pick the two inequalities. All you got to do is pick. All right. Now let's do the other one. Let's look at the third one. The third one, it looks like it's almost in y equals mx plus b. So I'm going to rewrite it. Y less than or equal to, because the pointy side is with y over here. So the pointy side has to be with y again. And I just rewrite -x minus 1. The y-intercept is -1. So that's definitely a point in this graph. That's definitely a point in that graph, -1. And then the slope is go down 1 over 1. Oh, snap. I think that we just found the red line. So I'm going to pick those two inequalities. And it's just that easy. So that's what you're going to see. Remember, you could see infinitely. You could see no solutions. You could see no solutions or only one part of the solution. Make sure that you know if something is dotted or if it's solid. Okay. And then it says, what is the point of intersection? So if I were to look over here, what is the point of this intersection? Okay, so the point of intersection is the dot that I just drew in red. And the point of that intersection would be the x value, which is 0.5, comma, the y value, which is -0.5. All right, so it looks like this is how you do it by hand, right? Now, you could also do these things in a graphing calculator. So if you use your graphing calculator, make sure that you are using it correctly with the correct sign. And all you have to do if you're using a T83 or T84, it's that you could graph it just as a regular equation, and it will give you the graph of the equation. Now, you have to make sure that you know if you're going to shade above or you're going to shade below, right? You could also just hit enter on it to change the inequality sign. You could also go to Desmos to be able to graph it if you need to use inequalities. They also have the inequality signs. This was Professor Cruz with eCruz Learning, and it's just that easy.